for his talk.
Okay, can you hear me?
Yes, we can. Strong and loud.
Okay, good morning, everybody. I will talk about my research, democratized framework for real-time facial motion capture using machine learning on digital humans. So the main research objective is to improve the empathic response of the actual commercial framework using open source tools and methodologies, making it affordable and easy to be replicated. But let's start talking about what is a digital human. A digital human is not a character like the movies or the video games because these are made and developed to play a specific role. It's not an avatar because these are renderings of real person to be used by the owner and virtualized in chat or social interaction in electronic communications. A digital human is a real person who take a process. His face, skin, facial expression are scanned to be replicated to get the most accurate of the detail of the eyes, the mouth, etc. And the hair is recreated by computer graphics. A control system is created, named Rig, and this led to use this digital human like a marionette using a special face device to capture in real time the movements of the face. So, as you can see, the real-time rendering of a digital human is one of the biggest challenges because need the best graphic engines. And this technology has inherited by video game engines, which has evolved to run realistic graphics in affordable computers. But why are so relevant? We know conversational assistant today is normal for us. The next year, this industry will save $8 billion to support the sales. To 2027, these savings will become up to $20 billion. And 85% of the people who consume products and services online will use chatbots to 2025. There is a big funding of companies doing research on digital human support to the e-commerce and customer support in technical support. Alexa, Siri, Cortana, they will have a face faster than we imagine. Pandemic lockdown showed us that the importance of need of interaction and customized support with something more than a text chat. And the question is, are these technologies easy to access to everybody? That's why we need to talk about open frameworks. Let's try to understand a digital human framework, the pieces and challenge needed to democratize it. The process began with a video capture using a special helmet with an RGB camera facing a real human. Second step, we need to do a 3D scan of all the expression of this human and disassemble it in different muscle groups of this specific person. We name this facial codification system. Using an AI tool, we need to recognize and process all this data. This way, the variables can be streamed to a digital marionette using the standardized control of the industry. The last step will be a real-time solving tool to drive the digital face using a real human face in life. So we will have to challenge to improve facial codification and expression recognition fast to make it in real time and trustworthy. We will need to improve the empathic rate bigger than the actual research of frameworks using deep learning tools. And last but not least, we need to be public and affordable to be replicated. So let's start with the facial expression recognition. But most important, real-time facial expression recognition. Solutions for this industry are exclusive, not open and expensive. Democratized options for students, researchers, and entry-level people are difficult. Some of the actual solutions are cubic motion, Bicon, and Faceware. And the past year, the only democratized option was to use an iPhone X with an AR kit, but we will talk later about why it's not the most reliable solution yet. Our face is more than just movement. Humans' emotions are based in muscle movements in a complex way, as you can see in this video of Melinda Ocel, a Facebook researcher who is working in this research and helping us. A single face can say more than a lot of things. Even the color of the skin and the eye can express emotions. To dissemble the way the face works, we have two facial codification for the face. The first is the MPG4, named Facial Action Properties, and this is the one IRKit use. This has been used since the late 90s and is one the students learn in the university around the world. This has 51 discrete controls, is not based in expression or muscle performance. And the second one is the Facial Action Code System, or FACS, based in 110 small pieces of information named actor units. It has been used since the 70s as a psychological foundation, and it constructs a relationship between muscles and emotions. The results have shown that has an improved empathic response when it's used in digital humans, and this is the one we will use for this research. For this research, we will work training with FACS databases like ECA and MMI. Thanks to these databases are not wild-based because these subjects are doing expressions under a control scenario. These are posed because best quality and closer to the face is better for the training. And these databases has a valid codification by experts. Now, to process the facial expression recognition into digital humans, we need to work on a specific deep learning method. A convolutional neural network will do the work. As you know, a convolutional neural network identifies small features in images to recognize and classify, using the hiding layer to detect patterns until the depth layers to recognize the specific actor unit of the face. A CNN has been used in the main expression recognition method in the last research paper for FACS on digital humans the last years. Lastly, we use a long short memory has increased accuracy. So this is nothing else than a time evaluation of the previous frames in order to let the neural network understand trajectories and tendencies to forecast. This method became a new way to work facial expression recognition the past year and will be included in this framework. Okay, great. Let's do a briefing of the process and the pieces to talk about the empathic response. And I mean the display of the delivery of the digital human face. To do this, we will need to talk about uncanny valley theory, accepted as the most important test for humanoid aliveness. This concept explains the way we feel comfortable with human faces, but in some ways it fails. For example, these two faces from 20 years ago, but the right one is more appealing despite old and low quality. Or a couple of digital human faces from 3 years ago, with the difference one looks like a corpse and the other is an incredible realistic. So to test the improvement of the quality and performance of digital human against the uncanny valley theory, the FACS codification has shown better results. To validate the weighted, the expression are aligned statistically using traditional tests like accuracy, precision, recall, etc. So we have a full panorama of the actual open frameworks for digital humans in real time, where must be certified by a FACS evaluator, must be used in digital humans field. Here, just two frameworks have FACS and FACS-Gen have success the 72% of the empathic response. Improve this number is part of this research. Second parameter needed to evaluate empathic response is based in the way to evaluate it. It's important to make emphasis realistic is not the best always, because some research results demonstrated high quality digital humans have no great results in tests like appealing, friendliness, or trustworthy. To improve the last parameter, we are using live interaction. The interaction with a real-time digital human improved the way we feel comfortable with it, as showed Dr. Seymour at SIGGRAPH 3 years ago. No actual frameworks evaluate interaction in real time. Last, we want to keep the things not expensive. So frameworks need to be easy to be replicated. So we will talk about this part. Actual facial capture headset, as you remember, are expensive and use traditional video interface to stream information to computer and be analyzed. So The exploration of this research looks to use computer vision and embedded system as an alternative. This allowed to use affordable computer like NVIDIA Jetson and computer vision cameras, making it affordable, easier to develop thanks to the embedded machine learning, and the most important, portable to be used as a traditional commercial technologies. Finally, to wrap up, let's see the framework with all the improvements in a different scope like this. This is the actual framework and the different step I talk about. And this is the general idea of the new framework to research, where a facial codification using facts and a 3D convolutional neural network to facial recognition, an improvement in the empathic response using validated facts, and a computer acquisition portable facial camera affordable to be used replicated by another students and researchers. So the contribution to our chip here, it's an updated framework with a deep learning and validated facts codification, an improvement up to the 73% in empathic response to an interactive digital human, and an inexpensive prototype of a head-mounted device. Finally, I want to share this early result of the past year. This is Dani, our subject. She was scanned using a 64 DSLR camera photogrammetry system. The scanning result is about 8 million of polygons. The quality of the texture is about 8K resolution, the process of the retopology of all the facial expression, and the final texture quality. This is the facial controls who will drive the marionette, and the result and quality of the digital human. This is the quality we got in the first iteration of our process running in a real-time computer with a GPU and an i9 CPU, all in real time with Unreal Engine. And this avatar was tested using a group of 22 volunteers, and we get a result similar to the percentage of empathic response of before research, helping to have a ground of truth of the research to the same as the state of the art. Second test series was to ask 10 volunteers to interact by 2 minutes with a live digital human in a Zoom call. So people can ask anything and a professional actress will improve the answers to these persons. The results of the perception of this person was this. Finally, the replication of the experiment of Seymour to have all these things working using a Vicon motion capture system, a Facebook real-time facial recognition system, and a real-time graphic server was another result. So I'm gonna do something. I wanna stop my screen to do a live test. I have my group here. Ana del Real, are you there? Ana del Real is a digital human who will be here as guest. So let me see. Ana?
Hi, how are you?
How are you? Good morning. So I will try to ask a couple of things to Ana del Real so she can improve and you can see the interactivity with this digital human. Ana, can you tell me what did you breakfast today?
I had just a pair of eggs and a slice of bread, but that's all digital, you know, so.
Okay. Okay, Ana, I don't know. Tell me, what do you think about the President Andrés Manuel López Obrador?
Oh, I don't know. I think I can say much because I am Mexican, so I like to be proud of my country, but I think many people have so much to say about him.
Okay.
President, I don't know.
Last question. Can you tell me what are your plans for this weekend?
I don't know. I'm just into internet surfing, so I think that would be interesting. Maybe Netflix and chill or something. I don't have many friends in here, but I would like to get to know more of them. So yeah, I think that's about it.
Perfect. Thank you, Ana. Bye-bye.
Bye.
Okay, so I will continue. So are you watching my screen?
Yeah,
Okay.
but recall the time, Carlos, please.
Yes, I just conclude. To conclude,
Okay.
this is a little brief of the future work of this research. We're gonna do an algorithm to permute and compute all the facts codification. So this way, facial expression recognition will be modeled and the model will performance. Develop the experimental computer vision XMD in a partnership with Faceware and improve the empathic rate of the digital human perception from an open framework. More to talk about, I want to share you this PhD research. It has a partnership with Architectural Art and Design School inside Tec de Monterrey. So this allowed to open the first course of digital humans in a university in Latin America, where myself and my team will teach all the content. Second, the achievement until today helped to create the first digital human startup company in Latin America. And third, the project became candidate to get around $50,000 from the EPIC mega grants. So let's cross the finger to get it out. Well, this is everything. Thank you so much.